Unit 1, Homework 2, covers linear equations and inequalities. Now, it covers quite an in-depth even solving linear equations and inequalities, but we're going to start at the beginning with slope. So first of all, when we're talking about a linear equation or a linear inequality, what that means is we're talking about a line. So every line has some sort of a slope that's associated with it. Slope is rise over run. It can also be denoted change in y over change in x. And the triangle is the Greek letter delta that means change. And now if you want to look at a formula in terms of slope, we know on a Cartesian coordinate system, y is my vertical axis and x is my horizontal axis. So if I talk about rise, we're talking about the y-axis. So rise would be the difference in the y values of my coordinates. Now, run would be my x values. So run goes this way. And those would be the difference in my x values. So these are the information that we need to work with the slope. So for our first example that we can work, let's go ahead and look at finding the slope. And we'll go ahead and do a quick graph too as well. So find the slope that travels between the points, let's say, let's do 6, 2 and 7, 4. So first of all, if we were to graph these on the Cartesian coordinate system, and we don't need to be exact about this, 1, 2, 3, 4, 5, 6, and then up 2. So here's our point 6, 2, because remember the first value is always our x, and our second value is always our y. So that's the same with both of these. And then 7, 4 would be over 7, and then up 2 more points. So 7, 4. It's kind of got a little crowded. Now if we talk about connecting these lines, we can see pretty clearly that this line has positive slope. If we read this line from left to right, it is going up. If I was driving in my car from left to right, this would be moving up. So what we say is this line rises from left to right. So it's always a good idea to graph these real quick first, even if it's just a little bit of a sketch. And that will kind of give us an idea about what we should be getting. Now to calculate the actual slope, what we're going to do here is we're going to use one of our formulas. Now slope is equal to m. We use m to represent slope from the French mountain, like a mountain would have a slope. Now remember, this is the change in the y values over the change in the x values. So the formula that we use here is the difference in the y's over the difference in the x's. Now what the important part is we always start with the same y and the same x, and it doesn't matter which one we start with. If we want to start with the 7, 4 or the 6, 2, I'll get the same answer either way. So for this one, let's go ahead and start with the 4. So if we take 4 minus 2, and then for my x values I need to start with the 7 because I started with the 4. I take 7 minus 6, so 4 minus 2 is 2. 7 minus 6 is 1, so my slope is 2, and that is my solution here. That is a value for my slope. Now what that means is 2 is the same as 2 over 1. What that means is no matter what point I start with, I would rise 2 units. So here I'd rise 2 and I'd run 1 unit to hit my next value. So that's what slope is. Now in your homework set you're going to be calculating a lot of slopes. Some will have 2 positive numbers, some will have 2 negative numbers, or some combination. So let's go ahead and work a little bit more complicated problem where we might have some negative values running around. So let's find the slope. And the 2 points that I'm given are going to be negative 9, negative 2. And the other point would be negative 7, negative 2. So again, I just want to do a quick curve sketch here. Or actually, it doesn't end up being a curve, a line, but curve sketch basically means plot the points real quick. And I can just look at this real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's negative 9, negative 2. And here's negative 7, negative 2. This is kind of an interesting one. So if I were to connect these, It's not a very exciting line, is it? It's -9, -2, and -7, -2. So what's happened here is this is called a horizontal line. Now if you notice, the y values are the same. And when I have the same y values, it's always going to cut the y-axis at that y value. So here I have a horizontal line, the same y values, the slope is equal to 0. Now the way I remember that is if I were to write a 0 on here, it would sit right on top. Now we're going to run into vertical lines a little bit too later. Now if I had to talk about this line, I would say it doesn't rise from right to left or either direction. It stays the same, it's constant. So let's go ahead and calculate slope just to see what happens here. Remember, that's the change in the y values over the change in the x values. Now it doesn't matter if we start, which point we start with. This one, I'm just going to call this one x1, y1, x2, y2. So we take -2 minus a -2. Now this is the trick. -2, and then I subtract my other -2. So you need the subtraction sign and the other sign of -2. Now my y values will go -7 minus a -9. Well, minus a negative is the same as a positive. So -2 plus 2 is 0. But down here, minus a negative is the same as a positive. -7 plus 9 is 2. So here I just get my slope is equal to 0. And that matches with what we thought from our curve sketch. So that's another really good example to show why a curve sketch is so important. Let's go ahead and look at another set of ordered pairs. Again, find the slope. And I really would recommend that you always graph the points. Just a quick little sketch to see what's going on, because that might give you a good indication of what your solution should be. So a quick little curve sketch. 1, 2, 3, 4, 5, 6. So here's the point 6, 8. And then 6, -7. This is an interesting line too. So I have 6, -7. -7. So here when I connect these points, what ends up happening is instead of a horizontal line, I get a vertical line. So let's go ahead and connect these points. Now notice it cuts right through the x-axis. So this is called a vertical line. Now a vertical line has the same x values. Now up here for horizontal, we had the same y values. Now we're going to have the same x values. Here we have undefined slope. Now a lot of people get these confused with zero slope, but this is undefined slope. So this is a vertical line. So the way I remember this is if I were to put a 0 on here, it would roll right off. So 0 doesn't make sense here. Now if I were to actually go through and calculate the slope, again, that's the change in y over the change in x, the difference in the y's over the difference in the x's, and it doesn't matter which one we start with here. I'm going to start with the left-hand one this time, but again, it doesn't matter. 8 minus a -7. I have to start with the same value again, over 6 minus 6. Minus a negative is the same as a positive, so I get 15. 6 minus 6 is 0, and this is the problem. You cannot divide by 0. And that's what makes this undefined. Now, whenever you run across this dividing by 0, if you plot the points, you better have the same setup where we have a vertical line. So again, it's important that we be able to look at those. Now, we haven't looked at a graph with a negative slope yet. So let's just go ahead and talk about negative slope real quick. So if I were to draw a graph, and we can make up any negative slope that we want. Now if we draw this quick line, we can see that as we go from left to right, the line falls. So again, with the negative sloping line, the line falls from left to right. Now we read the line just like we'd read text. So we start on the left-hand side of the line, and as we read across we can see that it's falling. So that falls from left to right. Now when my value for slope is calculated here, I'd have some value like a -2 or something similar to that. Now you don't always have to have numbers to calculate slope. You'll run into a problem in your homework set where you're asked to find the slope and we're given some values, let's say like A0 and let's say 0, -b. So to find the slope doesn't seem as easy, but really A is some positive number in the x direction. So we could just go over here and call this A0 because we're going some positive direction in the A. Now this one, I'd start at 0 on the x-axis and go down b units. So this would be the point 0, -b. So our resulting line would have a positive slope. Okay, so this one would have a positive slope. Now remember what positive slope means. It means it rises from left to right. Now we could also calculate the value for this slope. Remember, slope is change in y over the change in x, the difference in the y over the difference in the x. Now it doesn't matter which x or y we start with. I'm just going to start with this y value. So I'm going to have 0 and I subtract from here, and I subtract my other y value, which in this case is a -b, and then I'm going to go back and start with the same point where I chose my first y value, and start with that x and subtract the difference in the x's. So minus a negative is the same as a positive. So here I'm going to get b over a, which is a positive number because I assumed that a was positive. And we can see that in this particular case b is a positive number, but my negative value is just out front. So b over a is my slope. Now when we talk about the steepness of a line, you might be able to compare slopes. For instance, this is a positive slope, and let's say this is a negative slope, which it is. So if we have to talk about which one of these slopes was a bigger number, this positive slope would be a bigger number because it's larger on the number line. Now let's call this negative slope let's call it M1. Now we could also throw another negative slope up here. This is a negative sloping line as well. Let's call that one M2, but it's not as steep. So again, positive slope, I guess we didn't really name this one. Let's call it M3. So if we were to order these in terms of decreasing size, decreasing means to go from large to small. The largest number here is M3 because it's positive. These are both negative, so they're going to be smaller. Now when we talk about this in terms of slope, the steepest line is going to be the larger number, but it's a larger negative number, so it's going to be over here at M1. Now this particular slope, M2, is a smaller slope but in the negative direction, so it will show up right here in the middle. So let's make up some numbers. Let's say this was something like 4/3. Let's say this really steep one, let's say, was like -5/2, and this less steep one was still negative, but we'll say -1/2. So you can see that in terms of the number line, 4/3 would appear over here. Here would be my 0. Here would be a -1/2, and here would be a -5/2. So starting from the smallest to the largest, we would start with -5/2, but we're asked to look at decreasing, so I'll start with the largest and go down to the smallest. So those are examples of finding slope. And once we start finding slope, we start trying to find equations of lines. Now we have a couple different equations of lines that we're going to be using. These are important to know. You'll definitely want to have these in your notes. Now the first one that I want to look at is called the point slope form. Now when we talk about the point slope form, it looks like y minus y1 is equal to m times the quantity x minus x1. Now for this particular case, we can use this if we're given a slope and a point, and here would be our points, x1, y1, or 2 points. Okay, so this is good for given a point and a slope or given 2 points. We also have the slope-intercept form. Now for the slope-intercept form, it looks like y equal mx plus b. Now in this particular case, the m is familiar to us. That's the slope, just like it is up here. And b is my y-intercept. This means where it crosses the y-axis. Okay, so a lot of times you'll be given a point and a slope, and you'll say, what is the point-slope form? And then simplify this until you find the slope-intercept form. So let's look at a few examples here. Let's go ahead and find the equation of the line in point-slope form, given the slope is equal to, let's say, -3, and it passes through the point. Let's do, in this case, 5, -2. So I'm given a point over here and a slope. Okay, so first of all, to get started, I want this in point-slope form. Well, that's easy enough to do. So if I look at this in terms of point-slope form, I'm going to use my original point-slope form equation, and then I'm going to populate this, meaning I'm going to plug in values. So what stays the same here is the y, and the m, and the x. What changes, I'm sorry, the m will change too. What changes are the y1, the x1, and the m. So in this case, m is -3, y1 is -2, I can't use the negative that's already there, and my x1 is 5. So this would be called my point-slope form. Now when I'm talking about point-slope form, I never want to have two negative signs in the row, so I'd rewrite this. Minus a negative is the same as a positive. So I have y plus 2 equals -3 times the quantity, I need to have those parentheses, times x minus 5. Now my next step, or my next question is, go ahead and find the equation of the line that has that slope and goes through that point in slope-intercept form. Now remember, what slope-intercept form is, y equals mx plus b. Now there's several different ways you can do this, and if you learned a different way, you're welcome to use it. It doesn't matter to me. But what we want to do here is we want to think about what we have. We know we have the slope, that was equal to a -3. And it looks like to me we need to find this value of b. So we need to find b. Well, the easiest way I think there is to find b is to go ahead and plug in the values for 5 and -2 from up here. So y is -2, x is 5, plus b. So I have -2 equals -15 plus b, and then solving for b, I'd add 15 to both sides. -2 plus 15 is 13. These cancel, and I'm left with b is 13. So I'll throw this right back up there, and I have y equal -3, x plus 13. Now there's other ways to do that. You might have learned something up here where you would take and distribute through the -3 and then subtract the 2 across and solve. You get the same answer. So again, it doesn't matter to me what method you use as long as you use a method that gets correct answers for you. Now a lot of times when you're working through these, trying to find the different equations of the line, sometimes you're going to be seeing things like passing through the origin or passing through an intercept. So let's go ahead and take a look at the Cartesian coordinate system, and let's look at some special points here. The point in the middle is 0, 0. That's where the x and the y-axis cross. This is called the origin. Now wherever it crosses the y-axis, whether it's above or below the above or below the x-axis, this is called the y-intercept. and the x value is always 0, and then the y value is just some value of y. Now the same thing for the x-intercept. The x value is equal to some negative value of x in this case, and y is always equal to 0. So that's your x-intercept. So if I were to talk about this line, we would have an x-intercept and a y-intercept, just like that. Now I could also look at these points. This x-intercept would have a positive value, but notice the y value is still 0. So for an x-intercept, the y value is always 0. And down here, let's go ahead and look at the y-intercept. On my y-intercept, the x value is always 0. So these are some important things to know about the characteristics of a line. So if you're given the intercept, you also know an ordered pair if you take into account, x-intercept has a y value equal to 0, y-intercept has an x value equal to 0. Now I want to take a quick detour and I want to show you some things in MyMathLab, because you'll be asked to graph some lines and to use the graphing tools, and I just want you to be familiar with those when you come across them. So this is a problem in MyMathLab from this homework set, and it's asking you to graph the following equation in a rectangular coordinate system. Well, this almost doesn't even look like an equation. It almost looks just like a point. Well, it's y equal 2. This is a horizontal line that cuts the y-axis at 2. So what we would do is we would come down here and grab this line tool, because we don't have a curve, we just have a line, and I would choose a point where the y value is equal to 2. And it doesn't matter, I could choose anything along here. And then, if I want it to cut through 2, I need to choose some other value. Now it doesn't matter which one, and those are my equation. So as soon as I get that to graph, let's see here if I can scoot this up, I can click check answer, and it'll tell me I have the right equation, and we'd work from there. So you're going to run across some of these where you're asked to graph the equations in MyMathLab, and those are pretty easy to do. If you're given 2 points, make sure you graph the points. If they're asking for intercepts, make sure you get those as well. Next thing we're going to do is, we're kind of jumping around here. This particular outcome has a lot to it. We're going to be looking at solving linear equations. Now when we say to solve a linear equation, we don't have an x and a y. We just have a value where we're asked to find the value of x, which makes the statement true. So for instance, we could have x plus 3 equals 7. Well, the value of x that makes this true is 4. 4 plus 3 is 7. Now the way we would solve for that is we would subtract 3 from both sides. 3 minus 3 is 0. 0 plus x is x. And 7 minus 3 is 4. And we could check our answer here then by taking the 4 and plugging it back in for x, and then seeing if this is a true statement, and it is. 7 equals 7. So I know I have the right answer. Well, of course, ours are not going to be this basic. We're going to have a little bit more complicated than this. But we can solve these, and one of the ways that we can solve these if we have a fraction is by clearing the fraction. Now our first one that we're going to look at, and again, when you have a fraction, I prefer not to work with fractions if I don't have to, so I like to clear my fraction. So my first step here is to clear the fraction. Now you could clear the fraction by multiplying through by 3, because that would cancel here, and then multiplying through by 4, because that would cancel here. But the easiest thing is to multiply through by whatever the common denominator is, which in this case is 3 times 4 is 12. So we're going to multiply through by 12, and that means every single term. So this would be 12 over 1 times 28 over 1. I want to make sure everything is in fraction form. Minus 12 over 1 times x over 3 equals 12 over 1 times x over 4. Now this is the cool part about this. Nothing cancels here. I'm going to have to multiply 12 by 28 here in a second. 3 cancels into 12 4 times though, and 4 cancels into 12 3 times. So let's go ahead and grab our calculator. 12 times 28. Here it is, 12 times 28. We have 336. So I have 336. Then here I have a negative 4 times x is a minus 4x equals 3 times x, which is 3x. And then to solve, I would gather all my x's on one side, all my constants on the other. If you would prefer to move the 3x across and the 336 across, that's fine. And I get 336 equals 3x plus 4x is 7x. And then to solve, I have to undo multiplying by 7 by dividing both sides through by 7. And then I have 336 divided by 7. Check that on your calculator. And I get 48. So I get 48 equals x, and I always like the variables on the left, so I get x equals 48. Now there is a way to know if this is right before you submit it in MyMathLab or on a test. And what we would do is we would check it. So we would take this value and plug it back into my original equation. So I'd have 28 minus 48 over 3 equals 48 over 4. So I'm checking to see, is this true? Okay, 48 over 3, 16 times 3 is 48, so 48 divided by 3 is 16. 48 divided by 4 is 12 times 4 is 48, so 12. 28 minus 16 is 12, so I get 12 equals 12, which is a true statement here. So I know x equals 48 is my answer. So I think that it's easier to clear the fraction than anything else. So when I work these types of problems, I always talk about clearing the fraction. Now, like I said, we're jumping around quite a bit in this outcome. So now we have another topic to talk about, and that is interval and set builder notation. Now when we talk about interval and set builder notation, it's important to know the difference. So first of all, interval notation has to work with parentheses and brackets. So interval notation would be something like 2 to 7. Now this is not an ordered pair. What this represents are all the numbers on the number line that are between 2 and 7. Now notice these are parentheses. Now another way I've learned to work with these are hollow points. So a hollow point and a parenthesis are the same thing. So these are different ways to graph the same information. So this is interval notation. So this is saying every value between 2 and 7, but I don't equal 2 and I don't equal 7. I never actually reach 2 and 7. I just get very, very close, and that's what these hollow points and endpoints represent. Another example of a set builder notation would be something like, let's say 2 to infinity. Now I can never bracket infinity because I can never actually reach infinity. So we would start off at 2. Now we don't want to write all these values up to infinity because that would take forever. That's what this arrow means. Now 2 to infinity, I would bracket the 2 and go toward infinity, and I'll never reach it. And so another way to think about this arrow is going on forever indefinitely. Now if you're used to using parentheses and brackets and filled and hollow points, a bracket is a filled point, and this is going off toward infinity. So this is showing all the values of x that are covered by this interval from 2 to infinity. Now set builder notation is a little bit different. We use less than and greater than signs. So for set builder notation, for 2 to 7, what I would do is I would try and graph this in terms of 2 to 7. Now, when I have small to large, this means between. The two less than signs mean between. And neither one of them have an equal sign because I never equal 2 or 7. Now bracket 2 to infinity, I do equal 2. So this starts at less than or equal to. The equal sign means the bracket, and it goes off towards infinity. This still means between. So whenever I have two less than signs in a row, it means between. Equal sign and bracket, parentheses, and a less than sign You get close, but you never actually equal a value. So that's the difference between interval and set builder notation that you'll run across in your homework. And you'll run across infinity as well, and remember, never bracket infinity because you can never actually quite reach infinity. Now, one of the reasons we want to learn the set builder notation is so we can solve linear inequalities. Now, solving a linear inequality is the same as solving an equality, except I have to remember that now I have a less than or greater than sign. And I also have one rule that I need to keep in mind. Whenever you multiply or divide by a negative, you need to remember to flip the direction of the sign. Okay, so that's kind of our important thing here. So you need to remember to flip the direction of the sign. So for our first one, let's look at 5x minus 8 is greater than or equal to 22. So I'm going to isolate the variable by adding 8 to both sides. And I have 5x is greater than or equal to 30. Isolate the variable, you undo multiplication with division, and whatever you do to one side, you do to the other. And x is greater than or equal to 6. 30 divided by 5 is 6. So this is my answer in terms of interval notation. Now, set builder notation. Well, I think it'll be easier to talk about set builder notation if we can talk about a number line first. So 6, and then I go off toward infinity. Now if the variable is on the left, this shows me, or this points in the direction that my line needs to go. So it's going off toward infinity. There's an equal sign here, so I have a filled point. Now sometimes you'll see this asked for in terms of a bracket as well. So these mean the same thing. Now if I had to write this in set builder notation, let's see how that looks. Set builder notation would be between 6 and infinity, because this is going off toward infinity. Now, I have a filled point or a bracket, so I need to make sure I include an equal sign at the 6, but not the infinity, because remember, you can never bracket infinity. So this is set builder notation. So when you're solving these, those are the types of things that you're going to run into, is that positive and negative value, the less than, the greater than, bracket or filled, and so make sure you keep tabs on those things. Now sometimes when you're working, you might run into a problem that just really doesn't make sense. For instance, you might get something like x plus 2 is greater than or equal to x plus 3. Now when you try and solve this, you would subtract the 2 from both sides to get started. But when I subtract the x from both sides, that's when I run into trouble here. X minus x is 0, and I get that 0 is greater than or equal to 1. And then right there, when we say, what? 0 is not greater than or equal to 1. That means that there's no solution here. So this is a false statement. This means no solution. There's no value of x that will make this true. Now, this is also called the empty set. So these are all different ways to say the same thing. And we use a symbol to represent the empty set. It's a circle with a line through it. It's not a 0, it's just called the empty set. So when we're looking at a problem like this, remember, sometimes you can run across a case where you just wouldn't get a solution. In MyMathLab, there's another way they show you to solve, and that's by graphing. So let's go ahead and solve this one by graphing. Pop open MyMathLab. Okay, so this one says graph both sides of the inequality. So we need to start with this problem and graph both sides of the inequality. So we're solving this one by graphing. Now this one's not really set up to graph yet. So let's think about this in terms of side 1 and side 2. So if I distribute the negative 2, on this side I'd have a negative 2, whoops, let's make that look like a nice 2. Negative 2x minus 6 is greater than 6x plus 2. So what we're looking at here then is on this side a line with the slope of a -2 and a y-intercept of a -6, and this one has a slope of 6 and a y-intercept of 2. So let's go ahead and pop back into MyMathLab and graph those. Here we are. So let's see if we can fit these on the screen with our equations. So -2x minus 6. So this is a y-intercept at -6. 2, 3, 4, 5, 6. So -6. And it has a negative slope that's associated with it. So here, my negative sloping line, with my slope of a -2, I could rise 2 and run a -1. So again, this is just a quick curve sketch to kind of show us where we're at. Now over here, 6x plus 2 has a y-intercept of a +2, and then this has a slope of 6. So I'm going to rise 6, 1, 2, 3, 4, 5, 6, and then run 1, because that's the same as a 6/1. So again, this is a curved sketch. This is not an exact picture, but a quick sketch. Now, if I look at my options here, we can definitely see that this is up too high toward the x-axis. The lines are definitely not parallel. I'm not to the right of the y-axis, and so it looks like to me that D is our best bet here. So it says graph both sides of the inequality, and so we did our quick curve sketch, and we see that this matches pretty close with that solution. So let's go ahead and choose that one. And then next, what it's going to do is it's going to say, okay, now that you've found that one, what is the solution based on that? You know, how can we find the values of x that make this true? Now we'll see here in a minute how these relate to our solution. You know, why did we graph this? So let's go ahead and make a new page here. We have -2x minus 6 less than 6x plus 2. So we could subtract the 6x from both sides. Again, our whole point is to get all the variables on one side, all the constants on the other. 6x minus 6x cancel. I'd add the 6 across, and I get -8x is greater than 8. Now, in order to isolate the x, I need to divide through by -8. Now remember, whatever you do to one side, you do to the other. Now, this is our big remember here. You divided through by a negative, and when you multiply or divide by a negative, you have to flip the sign. 8 divided by a -8 is -1. If you don't, you'll get the exact mirror reflection of the true solution set. So this is our big remember. Whenever you multiply or divide across an inequality, you have to remember to flip the sign. You need to flip that inequality. And I'm going to write inequality here instead of sign just in case there's a negative. So we have to flip the inequality and make sure we call it inequality to make sure that we have clarity there. So x less than -1 is my solution. Now how does that relate to this picture? Well, it's kind of hard to tell, but this is where these points intersect. Right there. And I think this is the point, -1, 2, 3, 4, -1, 4. So, if you remember our line, this is -2x minus 6. This line over here is 6x plus 2. When is this one greater? Well, it looks like this one is greater from here all the way up. Well, what are the x values? The x values then go from here all the way toward -infinity. So I get from -infinity all the way up to -1, but I don't touch -1 because I don't have an equal sign here. So here I solved x less than -1. There's my set builder notation. This is my solution in interval notation. And you just need to be careful when you're working what MyMathLab is asking for. Are they asking for interval or set builder? So again, this is our set builder. And it's important you keep a close eye on that because you don't want to miss points on a problem or have to redo a problem just because of that. Now these problems get a little bit more difficult and you have to graph these on number lines, but you have the general idea of what we need to do and what we need to keep track of. Now there's two other special cases that we can look at when we're solving linear inequalities. So again, these are kind of the special cases you might want to look out for. If you run across these, a lot of times you get to a point at the end and you think, this doesn't make sense. But it's one of the special cases. So let's go ahead and have a look at an example of a special case type of problem. The first one that we want to look at, we have 3 times the quantity, y plus 2, minus 10y, and let's put a greater than sign here, y minus 4, and then that quantity 4 is times 2y plus 1, and then let's have a minus 1 on the outside. So right now this looks like we have a lot of simplifying to do before we get to anything close to being able to solve this. So on the left hand side of the equation, let's go ahead and take the 3 and distribute it to the parentheses. So we have 3y plus 6 minus 10y. Of course our sign doesn't change. And then over here what I'm going to do is I'm going to take the negative 4 and distribute it. So I end up with the y minus 8y. Negative 4 times 2y is a minus 8y, and a negative 4 times 1 is a minus 4. Of course, we just drag along that minus 1. Now on the left-hand side, we want to combine like terms. 3y minus 10y is a negative 7y. Of course, we have a plus 6 that doesn't combine with anything. And on the right-hand side, again, combine like terms. Y minus 8y is a negative 7y. Negative 4 minus 1 is a negative 5. So again, I want to move variables to the left, constants to the right, so I'm going to add 7y. And again, whatever you do to one side, you do to the other. Negative 7y plus 7y is 0. So I get 6 is greater than, negative 7y plus 7y is 0. So I get 6 is greater than a negative 5. Well, 6 is not greater than a negative 5. This is a false statement. So that means something. That has a particular implication. This is a false statement. That implies, and the equal sign with an arrow on the end means implies. This implies there is no solution. So when you work through an inequality and you get to the point where you come down to the very end, and maybe you come up with something that's true or false, okay, so here I end up with 6 greater than negative 5. There's no x's left. This is just a statement. This is a true statement. 6 is greater than negative 5. So this has an implication. The equal sign with an arrow implies the solution is all real numbers. That means I can plug anything into this I want, any number I want, and it will be a true statement. So the way that this looks when you put into your solutions in MyMathLab is from negative infinity to positive infinity. So that's my solution set. So that's one of the special cases. Let's look at another solution or another problem where we have a special case solution. Let's look at 4x minus 4 all over 7. And let's do less than or equal to 8 times the quantity x minus 2 all over 14. Well, this one, first thing I notice is I have fractions, and whenever we have fractions involved, we think, okay, let's clear the fraction. So for this one, let's clear the fraction by multiplying through. In this case, by the least common multiple or the least common denominator. And in any case, that's 14. Now we have to remember whatever you do to one side, you do to the other. So let's think about this as 14 over 1 since I have fractions involved, of course. And then 14 over 1 times 8 x minus 2 over 14. Now the whole idea of multiplying through by 14 is we get things to cancel. So 7 goes into 7 once, 7 goes into 14 twice, and here the 14s cancel all together. And let's see what we're left with. So I have 2 times the quantity 4x minus 4 is less than or equal to 8 times the quantity x minus 2. Okay, so here we'll take the 2 and distribute. And I end up with 2 times 4x is 8x minus 8. And then on the right, when I distribute, I end up with 8x minus 16. Okay, variables on the left, so I'd subtract 8x from both sides. Whatever you do to one side, you do to the other. 8x minus 8x is 0. So here I get negative 8 is less than or equal to a negative 16. Okay, well if we think about negative 8 and negative 16 on a number line, that'll help us decide if this is a true or a false statement. So here's, let's say 2, 1, 0, negative 1, negative 2. Pretty soon we come to a negative 8. Dot, dot, dot. And here we get to a negative 16. So negative 8 is larger than a negative 16. So this is a false statement. So false statement. Equal sign with an arrow implies no solution. So there is no solution. There's not one value of x that we can plug in here to make this a true statement. So a lot of times we denote this with the empty set. And the empty set symbol is a circle with a line through it. So these are 2 of the special cases that you might want to keep your eyes open for.